I'm Ethan Kwan, and today I'm going to be telling you about Lewis dot structures, how to draw them, and what they basically are. So what are Lewis dot structures? Well, that's kind of fun to say. So what is a Lewis dot structure? A Lewis dot structure is a model. And this model will help us understand how valence electrons work, and it's a great way to see how atoms bond. Okay, so this is what a Lewis dot structure looks like. Well, if we grab the periodic table here, one sec. Cut. Okay, so here we have our periodic table of the elements. So let's label these. So here's row 1, here's row 2, here's row 3. We're going to skip all the metals. They should be, I guess I should make this a little bigger. So zoom out. There we go. Okay, so let's label these here. So 1, 2, row 3, 4, 5, 6, 7, and 8. This is how many valence electron each row has. So for example, carbon has here. Carbon has 4 valence electrons. Okay, so let's draw a very simple one. Let's draw hydrogen's Lewis dot structure, which is really easy actually. So what you do is you draw the symbol for hydrogen, H, right? And then you draw how many valence electrons it has. And the easiest way to visualize this is having a box around hydrogen. And then what you do is you draw all the valence electrons lined up like this. So, for example, here's 1 valence electron, but that's it. That's all the valence electrons there are for hydrogen. So let's try, I don't know, phosphorus. And for phosphorus, we're only going to draw the valence electrons. Phosphorus is right here in the periodic table. So what are we going to do is we're going to only draw the valence electrons. And up here it says how many valence electrons there are. 5. So we're going to draw 5 dots. 1, 2, 3, 4. This is how I do it. And then 5. So you make a pair right here. There we go. Okay. So it has 5 valence electrons. Let's do one more, just for fun, okay? Let's do magnesium. How do we do that? Well, we put the symbol for magnesium, Mg, and magnesium is right here, so that means that it has 2 electrons, right? Yep. So 2 valence electrons means you go here, and then you can either go here or here. I would do here. So that's magnesium. Let's do one more. Let's do argon. Actually, no, let's do chlorine. So chlorine is going to be Cl. Chlorine is right here, right? Okay, so let me just change colors. Okay, and then what we're going to do is chlorine has 7 valence electrons. So we're going to draw a 7 here. So 7 dots. 1, 2, 3, 4, 5, 6, 7. And this is a great way to visualize all the valence electrons quickly. Now, what about bonds? This is the hard part. Okay, so there are... One sec, let me just grab this, copy it, so I can bring it down here. Okay, so what do we do? Well, what we can do is count first step into drawing any valence, any Lewis dot structure is count all the valence electrons. Count all the valence electrons. Ons. And then I can just put a 1 there. 1. Step 1. Okay? Step 2. Determine the central, I'm too lazy to actually write it, atom. And I'll explain what that is. Step 3. Draw all the valence electrons. 4. Question. Does the number of drawn electrons equal the number of valence electrons? If yes, draw one a single bonding line, I guess I can call it. If no, make a double pair. Draw a double pair. And then ask again. Copy. I guess this is step 5. Okay, ask again. Does the number of drawn electrons equal the number of valence electrons? If yes, you're done. If no, draw a triple bond. Okay, and then you're done. Okay, so I'll explain all of this. But let's just do a simple atom. Let's do one of them. One atom that's super essential. One combination that's super essential for life. H2O. Right? That's H2O. That's not how you draw it. H, or I guess hydrogen would be H, capital H, 2, O. Okay, so let's do H2O, or water. How will we draw the Lewis dot diagram for water? Well, this is how you do it. First, count up all the valence electrons. So if we do that, we get, well, let's see. For hydrogen, there's one valence electron for hydrogen, times 2, because it's H2, right? Times 2, which is equal to 2. And oxygen, which has, oxygen is right here in the 6th row. So it has 6 electrons times 1 oxygen atom equals 6. So 2 plus 6 is 8. 8, right? So that's how many valence electrons there are. Determine the central atom. What does that mean? Well, the central atom is basically the atom where everything will bond to. The easiest way to figure that out is, it's normally the one that has only one of. In this case, that's oxygen, because there's only one oxygen atom. Now, there's of course there are different cases which are exceptions to that rule, but let's just go with that definition for now. Okay, so to determine the central atom, that's oxygen. Draw all the valence electrons. Well, first of all, let's draw what H2O looks like. Well, H2O will look like this. Because oxygen is in the middle, we're going to draw all the valence electrons. Oxygen has 6. 1, 2, 3, 4, 5, 6, right? And hydrogen has 1. And the other hydrogen also has 1, right? Okay, so and you might remember that an atom, for it to be happy, needs 8 valence electrons, except for the first row, hydrogen and helium, which need 2. That's just a weird rule. We're not sure why. It's just like that. But most atoms in the rows 1 and 2 need 8 valence electrons to be happy. Well, we're gonna say they're happy, okay? Okay. Anyway, what we're gonna do is we are going to answer this question. Are the number of drawn electrons equal the number of valence electrons? Okay, so 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. So 8. 8 is definitely equal to 8. So what we're going to do is we're going to draw hydrogen here, oxygen here, and hydrogen here. Now, when atoms share electrons, it counts for both of them, which is really nice. Okay, so for example, so then what we do is we draw all the valence electrons. So now oxygen has 8 electrons, which makes sense because there's one from hydrogen and one from the oxygen atom. There's one from hydrogen this one and one from hydrogen this one, which is very nice of the atoms. Just change colors. Okay, for no good reason. Okay, so now I ask you, are all the atoms happy? Are all the atoms have their octet, which means 8 electrons? That's why this is called the octet rule. Well, yes, oxygen does have 8 electrons, which it makes sense because it's up here in the second row, so it should have 8 electrons, and it's happy. Hydrogen has 2 electrons, 1, 2, right? Or they're sharing, and hydrogen just needs 2. And the same thing with this hydrogen over here. This hydrogen also just needs 2. And it does have 2, right here. Right? Okay. So instead of drawing like this, we're going to draw it like this. This is a better way to draw it. We're going to draw lines to represent these bonds. H, O, H. They're too close together. I mean, it doesn't really matter, but okay. So we're going to draw lines between them to represent the single pair, or single bond, and then draw the lone electrons. So right now, oxygen has 2 lone pairs. Well, these pairs are kind of sad, so Sorry. Okay, so this right here is oxygens. Sorry, H2O's combination. But most people draw it like this because water is bent. We're gonna put oxygen here and hydrogen down here and hydrogen down here. If we do that, we get this is gonna be all the pairs, line, line, dot, 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 dot. Okay? That's how most people draw water. Okay, let's look at another molecule. Let's look at carbon dioxide. Carbon dioxide is CO2, right? So CO2. So first of all, count all the valence electrons. Okay, let's count all the valence electrons available here. Oxygen has 8 electrons, 6 electrons, sorry. 6 times 2, because there are two electron, 2 atoms of oxygen, so that's going to be 12. And then carbon has, and we can check our periodic table here, carbon is right here, it has 4, right? Okay, so carbon has 4 valence electrons, so 4 times 1 equals 4, obviously, right? Obviously. Okay, 12 plus 4 is 16, so we have 16 valence electrons. Now, determine the central atom. Well, carbon is the central atom here, right? Because why not? No, like seriously. Carbon is the central atom because there's only one of it. So carbon is going to go in the middle, and oxygens are going to go on the side. Now, next step. Draw all the valence electrons. How do we do that? Well, oxygen has 6, so 1, 2, 3, 4, 5, 6. Again, here, I'm just gonna delete this, copy, paste, move it down here. And carbon has 4, right? So 1 here, 1 here, 1 here, 1 here, right? Okay, so now what we do is, does the number of drawn electrons equal the number of valence electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. But if we try and draw a bond between them, watch. Here's what we can do. We can draw this, right? So we need, so if we want each pair, if we want each atom to have an octet, or 8 electrons. There's 6 here, so we need 2 more. And so this, and that. So there are 3 atoms. All of them need 8. So 3 times 8 is 24. So do we have 24 electrons? No, we have 16. So what do? We create a double bond. So let's create a single bond first. Oxygen, carbon, and oxygen, right? Okay, so if we create a single bond, these two are sharing electrons, so the number goes down to 20. No, sorry, it goes down to 18, but we still need one more pair of electrons to share, because here, look, if we need this, and we need this for the oxygens, right? We need to do this, right? We need 2 electrons for both, but we only have 16, but we need 20. So how do we get them? Well, we share electrons with carbon, like that. So now each of these lines represent two dots, or 2 electrons, or this, right? So now we have enough. Now we can quickly grab our octet. So this is 2, 4, 6, 8, right? And 2, 4, 6, 8. And carbon has all its electrons, because here's 4 and here's 4, right? So 4 plus 4 is 8. So now we have our electron pair, right? Okay, so here's the here is the Lewis dot structure for CO2. Does that make sense? Well, if it doesn't, I'll try and answer your questions in the comments. So, next, what we do is next, let's try something. That was kind of hard, so let's do something easy, or it's supposed to be easy. Let's try something like molecular nitrogen. Nitrogen is N, and molecular nitrogen is N2. So we have so nitrogen has 7 atoms, 7 electrons. No, wait, where's nitrogen? Nitrogen, where are you? Up there you are. So you have 5 electrons, 5 valence electrons. So N2, it has 5 electrons times 2 atoms, which is equal to 10, right? So we have 10 valence electrons. Okay, so how many? So N looks like nitrogen, molecular nitrogen looks like this. N, nitrogen, nitrogen. Now, how many do we need to make all the nitrogens have 8 electrons? Well, we can try that. We have 8 plus 8 is 16. We don't have that many. We only have 10. So what do? We make a bond. If we make one bond, we get 14 electrons, right? Because 2 of them are being used up, right? Boop. So 2 of them are one of them is being used up, right? So we can make one line between nitrogen. But we still need 14 electrons, right? So we still don't have enough. We can try making a double bond, but that only uses up, now we need one more bond, because right now you only have 12 electrons. We need 12 electrons to make a stable atom, or happy atom, I guess. But we only have 10. So what can we do? Well, drum roll please. Da, 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 da. We make a triple bond. So a triple bond looks like this. So nitrogen, line, nitrogen. And that works because each of these lines have 2 electrons. 2, 4, 6, and now nitrogen has just 2 electrons for each. Now just they're keeping the electrons. They're only keeping 2 electrons. 2, 4, 6, 8. Both of them have 8 electrons. They're happy, and that's why nitrogen is so hard to pull apart to make, fertilizer and stuff. Because it has a triple bond between the atoms, right? It's nitrogen with 2 valence electrons, with another nitrogen with 2 valence electrons. Triple bond, which means the bond between them is super strong. So that means it's really hard to make fertilizer out of nitrogen. That's why it's so hard. Okay, anyway, so that is how to draw Lewis dot structures. And actually, our title, we forgot about our title. Our title is right here. Hello. Hello, title. That's our title, and I'm not sure what that is. Okay. Anyway, thank you for watching. I hope you enjoyed this video. If you like this video, please subscribe. Also, if you also share this channel with others, and you just hit the like button. Just if you liked it, just hit the like button, because that's what the like button is for, right? Okay. Thank you for watching. I hope you enjoyed this video. Thank you for watching. See you at howtodoreason.com, and see next time. Thank you for watching. See you at howtodoreason.com. See you next time. Bye.